So this is going to be a lesson on 3.1, horizontally launched projectiles. So the do now question says you shoot a ball horizontally off the edge of a table. And so at the same time and at the same height, you let go of another ball that drops vertically. Now it might be hard to see in the video, but you see the yellow lines, right? You yellow dotted lines. You have a ball that drops vertically and another ball that goes horizontally. And the question is, well, which ball hits the ground first? Or do they hit the ground at the same exact time? And so they also ask you to explain it. Now I know most of you watching, most of the students in class, they said that the ball that drops straight vertically, will hit the ground first. Right? So, but the actual answer here, right? Let's watch it. Let's watch this. Is that if you see this, so there's no like trickery going on. You can see that in both situations where you drop a ball vertically and you launch a ball horizontally, you see that they both drop to the ground at the same exact time. And the question is why? Right? It's not something you guys would expect to happen, right? Why does this happen in the first place? Before we can actually explain it or understand it a little bit better, we do need to know a few things first. So let's do that first. Right, let's go. So again, this follows your notes. Right, this follows the notes, the attached document that to the actual material, to the post on Google Classrooms. So in real life, right, information for an object, we can define it in 2 points. Right, there's an x-axis and there's a y-axis, and because of that, what we can do, well, give me a second. Actually, okay, now it's good. Now it's good. So we have this on our screen. So let's actually make this a little bit bigger. And let's make this a little bit bigger. Now, all right. Now, so you see this image here, right? So you see this image here, and you see the path of the object as it goes horizontal, and make the size a little bit larger. That's good. That's fine. So it makes this path, right? But you also see, actually, I don't want it too large. But you also see the fact, well, this is your x-axis, right? This is your x-axis, and going to the right, and this is your y-axis. And we can pinpoint, right? We can graph the coordinate. We can tell where our object is if we have an x coordinate and a y coordinate, right? Along each of these points, along the path of this projectile, we can say that, well, it's on a certain x position, right? This is on a certain x position, and it's on a certain y position. There's an x and a y position to each of these points along the projectile's path. And so we can say that, well, there is a x velocity, right? There's an x velocity, there's a y velocity. Now, (2a). So, independence of vectors. Now, let's take a look at this, right? Let's take a look at this image right here. Actually, let me just take the entire screen. So, again, I show you the path of the projectile, which is the green ball. The path of the projectile is the green ball, and the x-axis is the blue ball, and the y-axis is the yellow or orange ball, right? So we can say that, well, there's a velocity in the x-axis, right? This is an x-axis over here. And there's a velocity in the y-axis. And well, the question here is, well, what do you guys notice? What do you guys notice is different about the distance traveled per second in the x and y directions? Well, look at the distance, right? Sure, the x distance, the distance traveled in the x direction looks to be about the same, right? It looks to be about the same. And so we can say that, well, it's traveling at a constant velocity in the x direction. So again, well, my object is traveling in the at a constant velocity in the x direction. But if we take a look at our y direction, right? If we take a look at our y direction here, you see that, well, that doesn't seem to be the case, right? That does not seem to be the case at all. On the contrary, you see that the distance increases in the y direction each second. Right? You see the distance increasing, and well, what does that mean? That means you're speeding up, right? You're speeding up here in the y direction, right? It's not a constant velocity anymore. You're speeding up in the y direction. Well, that's weird, right? It's not something you guys would expect, and here it is. In the x direction, your velocity is constant. In the y direction, you're speeding up. So we have two different values for velocity. We know they're different. And so we can come to the conclusion, well, there's a velocity in the x direction. Right? We can say that there's a velocity in the x direction, and it is completely separate from our velocity in the y direction. So now we go to the next question, right? And so I really just proved to you that there are two different things, right? The two different things for both x and y, and they're completely different. Let's move on to the next slide. And the next slide here says, well, does your acceleration due to gravity affect only the x direction or the y direction, or does it affect both directions? Well, think about it. Does your acceleration due to gravity act in the x direction? Does it pull you left or right? Right? Does it look like the object is speeding up in the x direction? Because that's what the question is asking you. Right? Is the object speeding up in the x direction? Well, no, so there cannot be acceleration due to gravity in the x direction. The only direction you're experiencing acceleration due to gravity is in the y direction. Right? In the y direction, you're experiencing acceleration due to gravity because you're speeding up. Clearly, you're speeding up. And that must mean that your acceleration due to gravity only affects your y direction, right? It only affects your y direction, right? It only pulls you down. It doesn't push you to the left or to the right, right? Your gravity is only downward. So that's why your object is speeding up in the y direction, right? It only affects the y direction. And so the second question here is, so what does the initial velocity of the object seem to be in the y direction? Well, we know in the x direction, our velocity is constant, right? We have a constant velocity in the x direction. That much is apparent. But what about our y direction? What about our y direction? Well, since our object is speeding up here, our object is clearly speeding up, which means we must have started from rest. And by looking at this, right, we can say that, well, our initial velocity in the y direction, right, vyi, right, our initial velocity in the y direction, so y would be your direction and I would be your initial. Your initial velocity in the y direction would be 0. We're starting from rest. right? You can clearly see that the object in the y direction is speeding up. So that's that, right? So our initial velocity in the y direction is 0, right? Our object has not fallen yet. Our object was only launched horizontally, and it was only when the object left the canyon that the object started going downward. So we can say that, well, it started with initial velocity of 0 in the vertical direction, in the y direction. All right. Moving on. So this is just something you have to copy, right? So basically to summarize, well, perpendicular vectors, right? Right angle vectors are independent of one another, which means that, well, if you have an acceleration due to gravity, it only acts in the y direction, right? It would only act in the y direction, because if it acted in the x direction, well, then our velocity wouldn't be constant anymore in the x direction, right? We know our velocity in the x direction is constant. So acceleration due to gravity only affects your y direction. So has nothing, it does not affect. So y vectors, right? Y vectors do not affect x vectors and vice versa. No matter how large my x vector is, has no effect on my y vector. Case in point over here in the GIF. Doesn't matter how much, whether I moved up or down, right? Sure. But I still crossed the same horizontal distance in the same amount of time. So this is something you have to get used to, right? All right. So solving problems, right? So now we get to the problem solving part. So we're gonna do really just something similar to Unit 1, right? We're gonna figure out our knowns, except on our knowns, there's only we have to split into x and a y column. So there are knowns for x side and knowns for y side. Now you'll see here that, well, the formulas that we use for both x and y are different. You'll also see that your y formulas kind of resemble your reference table formulas that we used in Unit 1. The only thing different is that I added a y. And on the x side, you see that there is no initial velocity in the x direction. There is no final velocity in the x direction, because our velocity in the x direction is constant. There is no initial, there is no final, it's always going to be the same. So, so let's get to solving some problems. Problem number 1. How much time does it take for the object to reach the ground? So you have an object launched horizontally. And we're going to split our nodes into x and y. So right here you can see that you have a velocity of 20 meters per second east, right? You launch it horizontally, so it belongs in our x direction because it says east. And we can clearly see it is going in the horizontal direction. 100 meters right here is your height, and it's a y vector thing, right? And well, that's going to be dy, right? Because it's measured in meters. Now here's the thing, it's going to be negative 100 meters because it is going downward. The object is going downward. And then now, well, that's it for the numbers. But there are two unknowns. And you have to think back to what we covered here so far. Right? In the previous slides, we said that, well, objects that are launched horizontally start with an initial velocity of 0. The object hasn't fallen yet. And we can also further say, well, what is causing this object to fall? Well, it's your acceleration due to gravity is causing the object to fall. Right? That's what's causing the object to be pulled to the ground. Gravity. And the question wants you to find out, well, what is the time it takes for the object to reach ground? And so what is t? Now, so which side do we solve for t? Because t can belong both sides. T is the same for both sides. There's no x, there's no y. T is on the same on both sides. So which side do we use? Well, we're most likely going to use our y side to solve for time, because if we use x side, we don't really have d, right? We don't know dx, so we can't solve for time using x side. But we can solve for t using our y side. And which formula on the y side are we going to use? Think back to unit 1. Which formula has everything you have? Well, dy, we know what dy is. We know what vyi is. Do we know what t is? Well, we're solving for t. We know what a is, and we're solving for t. So we're going to use this formula over here. So you're just going to plug things in. Dy is equal to vyi t plus 1/2 ay t squared. So dy is negative 100. 0 plus 1/2 negative 9.8 t squared. 1/2 times negative 9.8, negative 4.9 t squared. Divided by negative 4.9. And then you get 20.4. And then you have to get t by itself, so you square both sides. And then you get 20.4, 4.5 seconds. Okay. All right. Now, move on to B. So how far from the base of the cliff does the object land? Now, I wish I didn't get rid of my knowns, but I do recall, right, we figured out, well, Vx is 20 meters per second east, and time was 4.5 seconds, right? And so y would be, well, we don't care about y yet. So the question is asking, well, how far from the base of the cliff does the object land? The base of the cliff is over here. This is your base, right? This is the base of your cliff, and they want to know, well, how far from the base of the cliff does the object land? Well, what is this asking you for? They are asking you for horizontal displacement, right? They are asking you for horizontal displacement. And now that we have time, now that you guys figured out what time was from the last slide, we can use the x side. We can use our x side to solve for dx. So vx is 20. Dx is dx. Time is 4.5. Well, to solve for dx, we have to multiply on both sides by 4.5. 90 meters is equal to dx. All right. So that's our horizontal displacement. All right. So now we'll move on to 4C. So yeah, and from the last slide, we landed, what was it? 90 meters away from the base of the cliff. So 4C, so this is the third practice problem. So how far from the base of the cliff does the object land? Right, so we're gonna do our x. Now let me use a darker color. We're gonna do x and y. That's too, doesn't give me enough room to write the notes. So object is launched horizontally, so you start with an initial velocity in the x direction of 20.0 meters per second. And we know that the height of this, whatever this thing is tower. So it's in the y direction, so it's negative 60. Because again, the object does travel downward, right? The object starts at 0, and below 0 would be negative, above 0 would be positive. What else do you know? Well, you know that your initial velocity in the y direction is 0, right? You haven't started traveling downward yet. And your acceleration in the y direction is negative 9.8 meters per second squared. All right? And they wanted you to know, well, how far from the base of the cliff. So the base would be here. So base, and then you land somewhere, so that's going to be your dx, right? So you want to find out, well, what is my horizontal displacement? Well, here's the thing, right? We want to solve for dx. So we have to use this formula. We have to use this formula. We have dx, we're solving for dx. Vx we have. But do we know what t is? We don't know what t is. But can we solve for t? Well, we can, because t belongs on both sides. It is the same for both sides. Well, can we solve for t first? Yes, we can. We can solve for t on the y side because we have our 3 knowns and 1 unknown. So let's solve for time first on the y side. So dy is negative 60. Vyi is 0. Is negative 9.8. T squared. So negative 60 is equal to negative 4.9 t squared divided by negative 4.9. So 60 divided by 4.9 gives me something. I think it's like 12.24. And you square root both sides, and you get 3.5 seconds is equal to t. All right. Now that we know what t is, we can finally solve for dx. So let's use this formula. So 20 is equal to 3 dx over 3.5 times 3.5, 3.5, 70 is equal to dx. And so it travels 70 meters away. All right. All right. Good enough. So let's do the 4th question. Now this question doesn't require any math. Why does it not require any math? Well, because well, think about it. They're asking you for the horizontal velocity. They're asking you what Vx is just before it hits the ground. So they're asking you what, well, as the object goes to the ground, what is your Vx? What is your horizontal velocity? Right? But you guys know, you guys saw there is no acceleration in the x direction. Your velocity in the x direction is constant. Your velocity in the x direction is constant. There is no velocity in the x direction. I mean, there is a velocity, but it's constant. So our velocity, we launch with an initial horizontal velocity of 20 meters per second. Well, if our velocity in the x direction is constant, our horizontal velocity will not change. So our horizontal velocity is still 20 meters per second, and this question did not require any math. There is no acceleration in the x direction. Gravity doesn't pull you left or right. And the 5th question is just something you can do yourself. I'll just solve it with you guys. I won't explain it. Actually, I will explain it. So, projectile is launched horizontally at a speed of 20 meters per second. So you can say that, well, my velocity in the x direction is 20 meters per second. strikes the level surface below 3 seconds later. So time is 3 seconds. Approximately how high is the cliff? So they're asking you for a height thing, so that's a y thing, right? They're asking you how high something is. How high something is, that's a y-axis thing. Acceleration the x in the y direction is negative 9.8 meters per second squared. And your initial velocity in the y direction is 0. So we're solving for dy. We're going to use this formula, has everything we need. We're solving for dy. We know what VOYI is, we know what t is, we know what a is, and we know what t is. So dy is equal to VYI t plus 1/2 AYT squared. Dy is equal to 0 plus 1/2 negative 9.8 3 squared. Dy is equal to negative 4.9, right? 1/2 times negative 4.9. 3 squared is 9, and dy is negative 44.1 meters. Now, this is correct, right? This is entirely fine. But the question is asking you how high the cliff is. Pretty sure you guys have never measured something with a negative height. So we can say that is 44.1 meters high. Now the negative, you should have gotten a negative number. It should be negative because your object hits the ground. It is falling down. So it did travel a negative displacement. But they're asking you for the height of the cliff. So the height is a positive number. All right, that's the end of this video.